Alright, so we have seen case 1 and case 2, where case 1 is when your fx is in polynomial form, and case 2 where your fx is in exponential form. For case 3 is when your fx is either sine or cosine. So if your fx is in term of a1 sine beta x or a1 cos beta x, then your yp is equal to x to the power of r c sine beta x. So from this beta plus d cos beta x. Okay, right, let's try to do example 10. So we have y double prime plus y prime minus 2y. So as usual, first of all, we must find the homogeneous solution y h. Okay, so we have characteristic equation m square plus m minus 2 equal to 0. So I have m plus 2, m minus 1, okay, equal to 0. So I have m1 equal to negative 2, m2 equal to 1. So my YH is equal to a exponent negative 2x plus b exponent x. So this is my homogeneous solution. You must be very careful in calculating your homogeneous solution, because if you get wrong homogeneous solution, when you compare with your particular solution, you will get wrong answer. Okay, next we want to find yp. Alright, so my fx is equal to sine x. So you see here, your beta here is equal to 1. So your yp will be equal to x to the power of r. C, you can write c cos x or c sine x. Okay, so it must be similar. Here is beta is 1, here also must be 1. Plus d cos x. Right, so this one also must be same. Okay, depending on what is your beta in your fx. So you try r equal to 0, you will get yp equal to c sine x plus d cos x. Compare with yh. Compare with yh. Okay, so I have in YH exponent negative 2x and exponent x. In YP I have sine x and cos x. So no similar term, so we accept. Okay, so this is my YP. So this is my YP. Now I want to substitute in my original differential equation, so I must find YP prime. So YP prime is c cos x minus d sine x. I differentiate once, and YP double primes I differentiate once. Again, I will get negative c sine x plus negative, because we differentiate sine, we will get differentiate sine, we get cos, so we get minus d cos x. So substitute in the differential equation. In the differential equation, I will get, okay, so y double prime, so negative c sine x minus d cos x plus y prime plus c cos x minus d sine x minus 2y. So minus 2c sine x minus 2d cos x. So this is equal to sine x. Alright, so we collect everything with cos x. So I have we sin x first. Negative c minus d minus 2c sine x plus negative d plus c minus 2d cos x equal to sine x. Okay, so I compare my left and right hand side. So I have here sine x. So I have here sine x, and here also sine x. So I will have negative 3c minus d is equal to 1. And then when I compare cos x, here, and on right hand side I don't have cos x, so therefore I will get c minus 3d is equal to 0. So I solve simultaneously. Okay, solve simultaneously. Okay, so I will get my c equal to negative 3 over 10 and d equal to negative 1 over 10. So I hope you know how to solve a simultaneous equation. You can also use your calculator, right? So therefore your yp is equal to c, so negative 3 over 10 sine x minus 1 over 10 cos x. So yx equal to yh plus yp. So this is equal to a exponent negative 2x plus b exponent x minus 3 over 10 sine x minus 1 over 10 cos x. Okay, cos x. Yeah. Okay, so that is my final solution. Alright, and the final case, which is the fourth case, is when your fx is the summation. So you have a summation of case 1, case 2 and case 3. Okay, so if you have let's say you can have more than 2. In example 11, you have case 2 with case 1. So you have 2f. So f1x equal to exponent negative x and f2x equal to x. So what you have to do is you must find yp1 from f1 and yp2 from f2. And your yx is equal to yh plus yp1 plus yp2. If you have more than 2, summation of more than 2 f, so you have yh plus yp1 plus yp2 plus yp3 up to ypm. Alright, so let's try to do this example. So we have first, of course, we must find the homogeneous solution. This part is similar. So we have characteristic equation m square minus m minus 2 equal to 0. Okay, so I can write this as m minus 2, m plus 1 equal to 0. So m1 equal to 2, m2 equal to negative 1. So my yh is equal to a exponent 2x plus b exponent negative x. Okay, now I want to find yp. So find yp, which is equal to yp1 plus yp2. So first yp1. So f1x is equal to exponent negative x. Exponent negative x. So my yp1 is equal to, okay, x to the power of r d exponent negative x. So this is from case 2. So you see, here I have negative x, here also I must have exponent negative x. Okay. Right now, try r equal to 0. So you will get yp1 equal to d exponent negative x. So you compare with yh. Okay, compare with yh, we can see that we have exponent negative x. So therefore we reject. Okay, sorry. So we reject. Now we try r equal to 1. So we have yp1 equal to dx exponent negative x. So this one we can accept because no similar term. So this is our yp1. We compare no similar term, so we accept. no similar term in YH. Alright, so what we have to do, we must find YP1 prime. I'll just write it there. Okay, so YP1 prime, because we want to substitute in the differential equation. Okay, so YP1 prime, I will have negative dx exponent negative x plus d exponent negative x. So I will just go straight away without showing you the product rule now, because I believe you must be expert in doing the product rule by now. Okay, so now I will have d x exponent negative x minus d exponent negative x minus d exponent negative x. So here I will get dx exponent negative x minus 2d exponent negative x. So that is my yp double prime. So I substitute in the dE, the differential equation. I will have y double prime is dx exponent negative x minus 2d exponent negative x minus y prime. So y prime is negative dx exponent negative x plus d exponent negative x minus 2y, 2dx exponent negative x, and everything is equal to exponent negative x. Okay, so I can factor out exponent negative x. I will get dx minus 2d plus tx minus d minus 2dx, okay, equal to exponent negative x. So I can cancel out dx. So I will get negative 3d is exponent negative x is equal to exponent negative x. So therefore I will get d is equal to negative 1 over 3. Okay, so I obtain my yp1 to be, so d is negative 1 over 3, so negative 1 negative x over 3 exponent negative x. Okay, so this is my yp1. Next, I want to find yp2. Okay, so my f2 x is equal to, what is my f2 just now? Equal to x. So it is polynomial, case 1. So my yp2 is equal to x to the power of r. So you see the power is 1, so I will have only c1x plus c naught. c1x plus c naught. Okay, so try r equal to 0. I will get yp2 is equal to c1x plus c naught. Now I compare with my yh. Okay, so no similar term with yh. No similar term with yh. Okay, so no similar term in yh, because in yh both we have exponential. So therefore we accept this yp2. So this is my yp2. So yp2 prime is equal to c1, yp2 double prime is equal to 0. So again, I substitute in differential equation. Alright, so I have y double prime minus y prime. So y double prime 0 minus y prime c1. Okay, what we have? Minus 2y, so minus 2c1x minus 2c naught. Okay, so on the right hand side we will only consider this f2x, so is equal to x. So I will have negative 2c1x plus minus c1 minus 2c naught equal to x. So therefore I know that negative 2c1 equal to 1, which implies that c1 equal to negative 1 over 2. And I also have negative C1 minus 2C0 equal to 0. So I will have negative 2C0 equal to C1, which is negative 1 over 2. So C0 is equal to 1 over 4. Therefore, my YP2 is equal to C1 negative x over 2 plus 1 over 4. So this is my YP2. Okay, so finally, therefore, my yx is equal to yh plus yp, where yp is equal to yp1 plus yp2. Okay, so my yp is equal to yp1 plus yp2. Right, so I will get this equal, so my YH just now is equal to A exponent to x to A exponent to x plus B exponent negative x. Okay, and YP1 is, YP1 is negative x over 3. So minus x over 3 exponent negative x. And my YP2 is minus x over 2 plus 1 over 4. Okay, so now we already discussed all 4 cases of non-homogeneous second order linear differential equation. Okay, so first we must find the homogeneous solution. The homogeneous solution, we have 3 cases. First one is distinct real roots, second one is similar real roots, and third one is complex conjugate roots. Okay, and for the non-homogeneous, we want to find the particular solution because y, our solution y, is equal to yh plus yp. So to get the particular solution yp, there are 4 cases. The first case is when your fx is in term of polynomial. The second one is when your fx is in term of exponential. Third case is when your fx is either cos or sine. And the fourth case, if you have additional of any of case 1, case 2, and case 3. So we have discussed all 4 cases. Alright, so now for your exercise, I want you to try to do question 1 exercise. Okay, I would like you to do question 1 and question 2. Okay, from past year test 1. Okay.